a less romantic story of fertilization, but a more efficient one. My name, as Connie told you before, is Karen Mimran. I founded Edete together with other 3 partners over 3 years ago. Edete is not my first startup, though it had me reconnected with my family farming background. Since you've heard about pollination problems during the previous webinars, I'll go very quickly over the next few slides. Just as a teaser, this is how a normal supermarket looks like with bees, and this is what it might look like if there were no bees. Pollination is the transfer of pollen from the anther, the male part of the flower, to the female part. There, the pollen germinates and then fertilization occurs, resulting in the reproduction of seeds, fruits, and vegetables. Plants have developed different strategies to transfer pollen from one place to another. Wind pollination is used by cereal grasses and some trees. Animal pollination is mainly done by insects. The main agriculture pollinator by far are honeybees. So what is the problem? The world population is growing rapidly, and we need to produce more food on the current cultivated area without damaging natural habitat, forest, and open areas. About 75% of the world's crops rely on animal pollination for yield and for quality. But pollinators are disappearing. Wild insects are declining in numbers and diversity, while honeybees are facing colony collapse disorder. If this trend continues, we'll face a lot of empty shelves in our supermarkets. Honeybees are amazing creatures, but they require optimal environmental conditions, some of which are specified here, that prevent bees from getting us an optimal yield. Nature's preference for genetic diversification is another constraint. This is a typical planting chart of almonds. 2 to 3 varieties are interplanted in order to get cross-pollination, but often alternate rows are in bloom, which causes low setup and hence a low yield. Last but not least is agriculture real estate inefficiency, and this is where Edete's solution is a real long-term game changer. Some varieties have significantly lower commercial values than others, just like 1/3 of all almond cultivated land. Still, one has to grow them as pollinizers. We at Edete, however, use only one pollinizer tree in order to pollinate a few dozen trees of the most valuable commercial variety. Our vision is to solve the pollination deficiency challenge by developing and manufacturing efficient automated end-to-end pollination system, providing optimized pollination services to companies and growers. End-to-end means we produce pure, viable, but most important, germinable pollen, and then mechanically disperse it. By collecting pollen a year in advance, we not only solve the cross-pollination desynchronization problem, but can guarantee and even increase the agricultural yield. So how is it done? First, we mechanically collect flowers, separate pollen from anthers, and produce pure pollen, maintaining its viability and germinability. Using our proprietary method, we have been able to maintain good germinable rates of pollen stored for over 1 year. Then, we load the pollen into a dispersing unit, with barrel algorithmically self-reaching as near as required to the tree contour, and use electrostatic deposition onto a targeted stigma. Edete's application unit can work day or night. In the future, when fleets of drones can operate in the chaotic space between trees and not above, and get as close as possible to the tree contour, we can deploy the very same end unit and pollen on a drone. We're not the only one trying to solve pollination deficiency problems. We see 4 types of competition: mechanical blowers, whether electrostatic or not, robotic bees or drones, and botanical self-pollinating cultivars. To the best of our knowledge, All mechanical solution robots and drones will need pure, viable, and germinable pollen. Mechanical blowers are mostly opportunistic. Existing agriculture machines meant for different uses converted for pollination. They are based on brute force and using inefficient pollen consumption. So what have we accomplished so far? Our company was established in May 16, and by January 17, we had already conducted a very successful field test in almond orchards in Israel, producing pollen and dispersing it with a handheld prototype on branches covered with insect-preventing net. We got amazing results. By February 18, we've tested a full tree dispersal unit and a pollen production system and managed to grow yield by more than 10%. Another field test on August 18 was conducted in Australia to learn the characteristic of US cultivars grown in Southern Hemisphere, which enable us to double our testing efforts. And on February 19, we've tested generation pollen production and dispersal unit, waiting for the next month for the harvest results. In 2 weeks' time, we will be heading to Australia again to produce commercial amount of pollen and store it for a full pilot next year. Our target market is huge. Our first focus is rosacea and specifically almonds, but we will cover a much wider market in the future: apples, cherries, blueberries, cotton, rapeseed, and so on. The size of the annual almond market is $7 to $8 billion, and 80% of which is in the US, all of that in California Central Valley. Almonds are one of the first commercial trees to bloom during the winter and are thus susceptible to environmental conditions that reduce the effectiveness of bee pollination. Almonds require 2+ hives per acre. The value of almond pollination services in California is getting at $400 million annually. Our market penetration will be targeted to top-tier growers, 5% of the total 6,400 Californian growers that hold more than 50% of the cultivated area. Australian market structure is very similar to the American one. From a grower's perspective, our value proposition is secure and increase the yield and eliminating risks like weather and shortage of bees. Our pollination service is based on current cost of pollination, costs that are constantly growing, as you can see here represented by the blue line, following a constant growth of the cultivated area of almonds represented by the red line. Almond growers' income per acre was $5,100 on 2018. The cost of bee pollination is about $440 per acre, and the cost of Edete pollination service as the full replacement to bees is planned at $570 per acre. The grower will pay more for an increase of yield ranging anywhere in between $500 to $1,000 per acre. This is our team. It's a very multidisciplinary team with a proven track record and over 150 years of accumulated experience. Eilam Ran, Edete CEO, was VP of Engineering and R&D at Plasan, a global leader of vehicle protection for defense forces. Orin Bar, Edete's chairman, is a former VP of SCR, recently sold to Allflex and then to Merck. Elad Edgar is an inventor of harvesting solutions. Edete Engineering Lab is led by Asaf Borenstein, a mechanical engineer, and our biochemical lab is led by Dr. Joseph Fry. We're all very experienced. As you can see in the picture, we're not very young anymore. I'd like to thank you for your attention. If there's anything you wanted to ask me, you have my contact details just here, and you're welcome to address me with any question you might have. Thank you very much.
Thanks so much, Karen. That was great. I've got a lot of questions for you.
Okay.
Super interesting. I'd love to start just because I think that this is an area that really I know I don't know much about, and I think a lot of people probably don't. But if you could speak a little bit more to some of the I guess physical characteristics of pollen. I'm interested specifically. You said you've got a proprietary process to extend shelf life. You know, what is the normal shelf life of pollen? And even you can start to go into how some of the physical characteristics make it challenging to come up with these mechanical pollination processes. And I'll stop there, but we'll add on to some pollen-related questions.
Sure. Okay, to answer your question, let's start with describing the pollen. Pollen is very, very small. It's a 13 micron, 10 micron, anywhere in between 10 to 15 micron of size, very small, and it's not meant to be carried away by the wind. It is waiting for a bee or any other insect to come and to collect it, and then to move it to another flower. So it's not being carried away by the wind. It's not a very dynamic, and it weighs very little, but still it doesn't flow. It's not carried away by the wind. So the main challenges for us is how to disperse it in a way that we will lose as little as possible of the pollen, which is a very expensive element, and still disperse it in a way that it will land on the stigma, on the female part of the flower. So this is the main challenge, quantifying a very small amount of pollen and dispersing it over very large area is another challenge, which we've already solved. And maintaining the pollen, since usually a flower would open, an almond flower would open for 4 days, and the pollen will remain viable and germinable for 1 or more day after, if it was carried away by a bee, and again being placed on another flower. So in nature, the pollen is preserved for a very short time. What we've been able to do is to separate the pollen from the anther and preserve it for longer than 1 year, maintaining its germinability. It's not enough that the pollen will be viable, because not all viable pollen grains are germinating at the end, but we have been able to maintain the pollen both viable and germinable for more than 1 year.
Wow. And so is that, and you're doing that through a mechanical process or a chemical process? Like, is there, where I'm going with this is I immediately think, okay, how do you solve for the pollen spreading problem? The fact that it's not aerodynamic, right? I start to think, oh, you need some kind of surfactant or attractive mechanism to get it to the stigma. So,
okay, so
elaborate on that.
We're not mixing the pollen with anything. We're dispersing it dry. We're not mixing it with any liquid. So it's not really spraying. It is dispersing, because it's not a spray. It's not mixed with anything. It's a dry pollen.
Very cool. Okay, and then my next pollen question is, so you've got this process, I assume, down for almond, which I totally understand that is a very logical target market. can you speak a little bit to pollen variation between different crops, and does, you know, and kind of and then the corresponding R&D timeline for you for other crops?
Yes. We are testing with other crops, but very little so far. It's the same basic process of producing the pollen and dispersing it, especially the dispersal part, but we need to come up with special parameters of the production process that will maintain the germinability of different types of pollen. This is why we've tested both in Israel and in Australia, because there are different type of almond cultivars, but we have already tested successfully with apples and cherries, but we're not yet pollinating with apples and cherries. It will take us, I think it will take us a year for each crop to develop those parameters in order to be able to pollinate. So after we successfully go into the almond market, we will move straight forward to other crops as well. We are testing with other crops right now. For instance, kiwi pollen is much lighter and smaller than the almond, and some of it is blown in the wind, so it's much easier. And I must say that in New Zealand they do mechanical pollination for kiwi, so we are testing with that too. I think in New Zealand it's a solved problem. They have mechanical blowers that supply mechanical pollination, but as a supplement to bees. It would never be instead of bees. It's always a supplement, whereas we can be a fully replacement for the bees. And yes, we are looking now at rape seeds and cotton as well. I cannot really tell you right now when we will have the right parameters for each of those crops pollen. We're still testing.
Thank you. Super interesting. That kind of gets me to you started to talk about blowers, but I think the next big question that I often hear in this kind of artificial or supplemental artificial pollination space, or mechanical, I'll say, not artificial because it's real pollen. But the other side of the equation is the equipment to actually do it. So can you speak a little bit to, one, how that plays into your strategy? It sounds like you aren't manufacturing any yet. Do you intend to design equipment, or do you partner with other equipment types? Yeah.
We've already developed 2 generations of prototypes of the pollinating unit. And up to now, it's been done with companies here in Israel, whereas in the future we might move the production to other places in the world. But we do already have 2 generations of prototypes of the dispersal machines. They've been tested in Israel this year and last year, and we're improving them. So this is why the 2nd generation came. And by February next year, we will be pollinating with another generation prototype, and we hope that this will be a very close to go-to-market prototype.
Got it. Thanks. Okay, so then let's speak quickly a little bit to business plan a little bit more. So am I correct in understanding that you've kind of got, one, pollination as a service, much the way the commercial pollination industry already exists, and 2, it sounds like because you have this ability to elongate the shelf life of pollen, you've also got the capacity to license or almost sell pollen. Is that, yeah, can you speak a little bit to your business model, and am I correct in that understanding, or?
Yes, we will be able in the future to sell pollen to other mechanical pollinators or whoever want to use it. The thing is that the pollen is very expensive, because once you pick up the flowers from a tree, in order to produce the pollen, you must compensate the grower for losing the yield of this tree, because once you picked up the flower, there would be no fruits. So we are now working on the optimization of the amount that we pick and the amount that we disperse. But we will be able to contract with growers in the future in order for them to grow trees only for pollen. And our business model include a full compensation for the growers for the pollen produced for the trees, that they will not produce almonds, or other fruits, but they will produce pollen. And we can contract with them in advance and promise them the yield in advance, because the trees we know how much flowers more or less that we will get every year, and so this way we can contract in advance with growers that will grow trees for pollen and not for fruits. Since we are very efficient, and we need less than what the growers usually plant for cross-pollination, then it will be worth them a while to grow trees for pollen for us.
Understood. And then that brings me right to, is it possible to create pollen like in a lab kind of setting? Is that something you guys have looked into at all? I mean,
that's a great question. Think about human fertilization. Do we know to develop a sperm or an egg in a lab? No, not yet. Probably it will be done in the future, but till then we're not producing any artificial pollen. Not yet.
Okay, we're not quite there yet. Got it. I'm skipping too far into the future. Okay, so then last technically question, and then I want to see. We always like to conclude with how can our audience help you? But I want to ask first on pricing. I know you said you guys are slightly more expensive, but it's made up for in improved yield. Do you see your costs driving down as you guys develop and kind of streamline equipment, or do you intend to keep at a kind of higher price point than standard pollination?
That's a very hard question, because I'm not a prophet and I cannot foresee the future. But the better our pollen production process will improve, if the more we can improve the pollen production process, we can reduce the cost of pollination, because it's all about the pollen. The pollen is the most expensive part of this whole thing.
Can you give us a sense of, like, per unit weight, how much pollen costs to acquire?
If you buy pollen in the U.S., if you buy almond pollen in the U.S., I believe you'd pay $600 per 100 grams of pollen. I think these are the prices.
That's expensive. Okay, got it. All right. Well, okay. Well, I'll be working on the lab production pollen, but until then, but I want to. We always like to end it. We appreciate your time here, Karen, and we like to make sure that this is a little different. It's not a live recording, but we want our audience members to be able to help you as well. So this is kind of your chance to ask, knowing that we've got a farmer audience, we've got an investor audience typically, we've typically got some other entrepreneurs on the line who will be viewing this. How can we help you? What do you guys need right now?
We are looking at the next round of fundraising to be started by the end of this year, or maybe beginning of next year. So there'll be another round of fundraising. If anyone's interested, I welcome you to write or call me or anything, or any way connect with me. And we are coming to the US for the Almond Board conference held in December. So if anyone wants to talk with us there, to get to know us, maybe to collaborate in field test or anything similar to field test, we'll be happy to connect before December and during the conference in December that attracts many almond growers there. And I think that's it.
Great. Okay. Well, thank you again. And I learned a ton. This was really one of the most informative webinars I've been on for a while. I hope that audience members, you feel the same way. As a reminder to everyone, we host these calls every week on Thursdays at 3 p.m. Central, 4 p.m. Eastern. You can register for Agrifood Conversations by going to agrifoodconversations.com. There you can also view past recordings. A replay of this webinar will be emailed to all registered attendees within 24 hours. And if you know someone else who might want to see this webinar on replay, we encourage you to share it with them, let them know that they can register on the original webinar link to gain access. With that, Karen, I want to thank you again. This was a great conversation, and look forward to seeing where Edete goes.
Thank you very much, Connie. It was my pleasure. Are we done?
Yeah, we're done. Susan, I don't know where you are. I can't stop the recording, but it can just get trimmed, I think. I hope. Well, Susan's gone. Susan, help.